The goal of this video will be to develop some intuition about the product rule for finding derivatives. Before we start doing the problems, let's just look at what the product rule is. So just for recap, the derivative of the product of two functions, let's say f and g, differentiated with respect to x. To do this, you just write the first function, multiply it by the derivative of the second function, and do the same thing vice versa. So then you write the second function and multiply with the derivative of the first function. Now, using this idea, we can start solving a few problems. So let's start with this one. So herein you can see that y is a function and it's dividing sine of y. So you might be tempted to use the quotient rule. However, the quotient rule seems to be a bit more laborsome when solving problems. So when you see a polynomial like this, an easy polynomial, what you can obviously do is you can write 1 over y as y to the power of -1. And look what that gives us. This gives us that f of y, the function, is equal to y to the power of -1 times sine of y. We do know what are the derivatives of both of these functions, and now we can apply the product rule. So now we can write that df over dy is equal to, let's first differentiate the first function. So let me write d of y to the power of -1 divided by dy times sine of y plus, now we do the same thing, but now sine of y gets differentiated. So d of sine of y with respect to y multiplied by y to the power of -1. And this is just the power rule. This is just, you just apply x to the power of n rule here. This gives you -y to the power of -2 times sine of y. Add to this, the derivative of sine of y is cos of y. This is being multiplied by y inverse. Now if you want to clean up the expression a little bit, this will look like y cos y, y times cos of y, minus sine of y divided by y squared. And that's the derivative of this function. Let's move forward. Let's say you wanted to find the second derivative. Notice that this is the second derivative, not the first order derivative. To find the second order derivative, what we just need to do is we just need to differentiate the function twice. So this is the product of two functions, x to the power of 5 and tan of x. So you can write, let's first do the first order derivative. So df over dx, that is equal to, first you differentiate x to the power of 5, that is being divided by d of x, times tan of x. Add to this, well, the derivative of tan of x, and multiply that by the function, the other function that you have. And now this is fairly simple. This just gives you, well, this is just the power rule. So 5x times x to the power of 5 minus 1 is 4 times tan x plus the derivative of tan of x is sec squared of x, or 1 over cos squared x, whatever you want to call it, times x to the power of 5. And if you just want to clean up things a bit, you can also write this as x to the power of 4 times 5 tan x plus x sec squared x. But we're not done here. We still need to redifferentiate whatever we have got here, since we need to find the second order derivative. So what we can do is we can write that the second order derivative of this function is equal to the derivative, the sum of the derivatives of these two things right here. So you can write d over dx of 5x to the power of 4 times tan of x plus d over dx of x to the power of 5 times sec squared of x. And now these are two different questions. Both are the product of two functions. And now this second order derivative question boils down to the first order derivative of two things. Let's now just do whatever we have done again and repeat it. So let me do this one in green. Let me just take white right now. And let me do this one in red. And again, let me do this in white. And let me do this in red. Now, immediately, you can just repeat what you have done before. And you can write this as d over dx of 5 times x to the power of 4 times tan of x plus d over dx of tan of x times 5x to the power of 4. Add to this, well, we do the same thing again, but now instead of tan of x, you write sec squared of x. So we would write d over dx of x to the power of 5 times sec squared of x plus, well, I had to do that in red, so anyways, plus d over dx of sec squared of x times x to the power of 5. And that we're pretty much at the end of this problem. This is, well, if you want to do that apart from this problem, so this, the derivative of x to the power of 4 is 4x cubed, just by the power rule, and you're multiplying that by 5. So you get 20x cubed tan x, so this term's taken care of. If you look here, the derivative of tan of x is actually equal to sec squared x. So this is 5x to the power of 4 times sec squared x. Then again, to this you add this term's taken care of. This term, the derivative of x to the power of 5 is 5x to the power of 4, and you're multiplying that by sec squared of x. In the end, the last term, this requires a bit of chain rule. So if you don't know about chain rule, you can just leave it for granted. But anyways, if you want to apply the chain rule, we do know that we can write this derivative, sec squared x derivative, as the derivative of sec squared x with respect to sec x, and multiply that by the derivative of sec of x over with respect to x. And this right here is equal to 2 sec of x, and this derivative of sec of x that we know is equal to sec x tan x. And this is getting multiplied by x to the power of 5. Again, if you want to clean up the expressions a little bit, you can do that, but this would be the answer to the problem. Let's look at the last one. And this one's a bit tricky, since you see that there is a product, and you might be tempted to do that. But my strategy, and what I think will be better, is to think about whether you can simplify the polynomials, since all of these are polynomials, and doing algebraic manipulations is a lot more easier than playing with the product rule, since there are just a lot of terms. And notice you need to find the third order derivatives. If you look closely, you can see that there is a y plus 1 term and there is a y minus 1 term. If you multiply these two together, that gives you y squared minus 1, y squared minus 1 squared, or y squared minus 1. And again, this thing is getting multiplied by y squared plus 1. So y squared plus 1 times y squared minus 1, that is equal to y squared squared minus 1 squared. And that is equal to y to the power of 4 minus 1. And that's pretty interesting, since if you would have started with product rule here, that would have given you a lot of trouble. Now, just by some simple algebraic manipulations, you have arrived at an equal expression. And now this is also equal to w, so let's just start with the first order derivative. So dw over dy, that is equal to, well, the constant term does not have a derivative, its derivative is just equal to 0. Y to the power of 4 will have the derivative, well, that's going to be 4y to the power of 3. And now you have to find the third order derivative, so let's keep going. The second order derivative, that is going to be equal to, well, you just write the 4 as it is, and the derivative of y cubed is going to be 3y squared, so this will be 12y squared. And the third order derivative, finally, is equal to, well, you first write the 12 as it is, and then you write the derivative of y squared. And the derivative of y squared with respect to y is just 2y. This gives you 24y. So try that. try this problem using the product rule and see whether you get the same answer. But definitely doing a bit algebra is helping us a lot. See you in the next videos.